In a graph, we can talk about something called an Eulerian path. This is a path that starts off at some node in the graph, let's say A in this case, and it moves along the edges from node to node, hitting every edge exactly once, and then ending at some node of the graph. So in this case, we have an Eulerian path that started at A and ended with D. Euler, by the way, was a famous mathematician, Leonhard Euler. He made a number of contributions to discrete math and ultimately computer science. Here's something that we can notice about a graph. If it has an Eulerian path, notice what has to happen to all the nodes along the path. So here's what we did in this example. We went from A to B to D to A to C to D. So now let's consider the degree of all the nodes in the graph. So A has a degree of 3, B has a degree of 2, D has a degree of 3, and C has a degree of 2. So notice that these nodes B and C, which were not either the beginning or the ending of the path, the Eulerian path, have an even degree, and that has to be what happens. All the nodes that are not the beginning and ending nodes have to have even degree because the path has to go in one edge and out another edge. So every time that node gets passed through, two of the edges are visited, and none of them are visited twice and none of them are skipped. So it has to be that all these nodes that are intermediate on the path have even degree. The beginning and ending nodes are different though. The path starts off at A and it leaves A along one of the edges, and that consumes one of those edges. And so the beginning and ending nodes, A and D in this case, have to have odd degree because in addition to any times that the path moves through them and comes out the other side, it either leaves in the beginning or enters at the end without a corresponding other side. So those have to be odd, all the other ones have to be even. And it turns out that this relationship is an if and only if. That is to say, if a graph is connected and has exactly two odd degree nodes, then it has an Eulerian path, and if it's not, then it doesn't. Now, there's one exception to this. What if all of the nodes in the graph are even degree? Let's take a quick look at a special case here. Here's a graph with 5 nodes, and the degree of all the nodes is even. 2, 4, 2, 4, and 2. Can a graph like this with only even degree nodes have an Eulerian path? So one possible answer is no, the start and the end edges of the path have to have odd degree, which they wouldn't in this case, so it can't have an Eulerian path. Another possible answer is yes, but it depends on the particulars of the graph in question. So some graphs with only even degree nodes have Eulerian paths and some don't. Another possibility is that the answer is yes, all such graphs do. Any graph that's connected and has only even degree nodes will have an Eulerian path of a particular form. And another possible answer is yes, because all graphs do. You can't really have a graph that doesn't have an Eulerian path.